Let's talk about today's main technical topic, not topping, an idea that bears repeating. Come on, I'm trying. Validations and filters. So a lot of the emphasis in software engineering is trying to reduce repetition, make good use of reusing existing code. And one challenge is when the thing that you're trying to reuse is not sort of a piece of code located in sort of one place, but it's sort of a cross-cutting concern. It's something that you have to pay attention to at various points in the app. So a cross-cutting concern is something that is a consideration that arises in terms of execution and code flow, could arise at a bunch of different points in the app, but you would still like to avoid duplicating any code or logic that has to do with it. So a simple example of something like that is back to our simple Rotten Potatoes app. Suppose we want to enforce that movie titles have to be less than 40 characters. So the naive way to do this is every place in the app where a movie's title might get edited, so the form for creating one, the form for updating one, the form for retrieving one from TMDB, you could define some check function and then make sure that every place in the app where a movie might be edited, you arrange to call that function. That's obviously pretty brittle because now you have a bunch of repeated calls to the function all over the place. You have to make sure that every one of them gets updated. So what is a way to handle concerns like this, still keep the information in one place, but avoid that level of repetition? And to do that, we will bring in a couple of ideas from aspect-oriented programming, which my guess is for most people is probably a phrase you haven't necessarily worked with before. The idea of aspect-oriented programming is exactly that you can capture these cross-cutting concerns in a way that is almost independent of where in the app you're going to use the concerns. So advice is a specific piece of code that implements a cross-cutting concern. So the code that checks, let's say, whether the movie's title is 40 characters or less. Point cuts are places in the app where at runtime you would like that code to take effect. And if you put together the advice plus a point cut, that's called an aspect, hence aspect-oriented programming. And this is a mechanism for drying out your code so that you can put this knowledge in one place, but rely on it essentially being accessed from a bunch of places. So how does this work in Rails? Rails is not fully an aspect-oriented language. A true aspect-oriented language would basically give you a lot of freedom in what kind of advice you can define and how you specify the point cuts. But in Rails, because it's a model view controller framework, there are a couple of specific places where it makes sense to allow these point cuts to happen. So the first example that we'll look at are called validations. And a validation, from the advice point of view, is a set of invariants that you would like to be true about any instance of a model that is going to get saved. So in our simple case here, where what we would like to be true is the title is less than 40 characters. And then the question is, where do you define that advice? And how do you specify, or where are the point cuts, the places where, even if you don't explicitly try to call the function, the advice is going to get applied? So here's how that looks. If we reopen our movie class and we add these two lines, the first line says, I would like to validate that the title attribute of movie has the following properties. First of all, that it is present. So it can't be blank, can't be the empty string. And that we check its length, and it has to be a maximum of 40. As you might expect, there's a lot of other options that could go with this. You can specify a minimum and maximum, and you can check it against a regular expression. But again, as usual, my goal is give you a sense of how this works, and then you can go look at the exhaustive version. I would also, in the second line, say I'm going to validate that in terms of the release date attribute of a movie, it just has to be present. I'm not asserting anything about, it has to be within a certain date or something like that. But it has to not be blank. So when do these, and I could also say, if I want to do something a little more customized, suppose I only want to have movies in my database that were released 1930 or later, because that's when the MPAA movie code actually went into effect. So movies made before then actually don't have ratings in the sense that we think of them. I can define my own custom function that basically checks that if the movie has a release date, or if it's been specified, and the release date is less than some threshold, then I will add an error saying that the release date must be 1930 or later. Again, don't worry about the syntax. Think about what's going on here. I'm defining a custom validation that isn't sort of a simple thing I can express with one of the built-in validation checkers. And then on the third line, it just says, in addition to the specific attributes, title and release date, also run this function. And this function can do whatever it wants. It can look at any attributes of the object. It can enforce any conditions. It can enforce things that are time varying. It can look at relationships between different fields. So basically any invariant that you want to assert. And just to do one last example, I can also say, well, if the release date is greater than, I'm going to pick a random other date here. I'm going to say that a movie has to have a rating. So here's validates rating. The rating is included in this array that I've defined up here, which contains the standard movie ratings. But I only want to do that if the movie is not grandfathered in. So what's grandfathered? It's another function that I can define. All right, so in this case, I'm saying a movie is grandfathered if its release date is greater than some class variable, the grandfathered date. So all of which is to say that I can do the first two examples, title and release date. Those are sort of built-in examples of things you can check. I can write a simple function that can look at any aspect at all of the model and enforce any validation check on it. And I can condition any kind of validation on some predicate, so that if this predicate is true, then the validation isn't run. That's the basic idea of how validations work. And in a moment, we'll talk about when these things actually get applied. So this is the code that verifies whether certain conditions are always true of a model instance. And now the question is, how do we determine when does that code get run and why does it get run? Before I do that, I wanted to address a question.
I was just wondering, when you define your own custom validator, is it like a different function call? Because I know it says validate instead of validates. Is that just like
Yeah, it's just syntax. But I think the question is why are some of them validate and why are some of them validates? The general answer is validates is followed by an attribute and then some conditions on that attribute. But validate, without the S, is I'm going to provide my own custom function, please call it. It's just syntax. There's no good reason, sadly. OK, so the next question is, when do these pieces of code actually get called? When do they do their stuff? And by the way, what is the stuff that they do? You can get a clue from my custom validator function, because if the condition that it's looking for, meaning that the release date is less than this, if that condition is true, then it adds, it's calling errors.add. What is errors? Errors is actually an object that's included with every instance of an active record model, and it's where all of these validation functions are going to stash their error messages if they find that the condition's violated. So for example, when we run this code and it finds, for example, that the title is not present or that the title is more than 40 characters, the built-in validator will say errors.add, and you'll end up with something like title is too long, 40 characters is maximum, or something to that effect. I don't remember the exact canned message it gets. But errors is basically its own object, right? So the general pattern here is we've set up some code that is going to look at some conditions on the model to make sure that the model is sort of valid, right, that these conditions are true. And if any of the conditions are violated, it's going to add one or more messages to this other object called errors, which is part of the model. And if the validations fail, we can look in the errors object to see exactly which ones failed and what went wrong. So when does this get called? The key idea of this slide is it gets called every time you save. That's, if you remember nothing else from this slide, remember that one thing. When do those validations get called? Right before something is about to be committed to the database. That could be because it's being created for the first time. That's the path on the left. It could be because an existing model instance is being updated in place. That's the path on the right. And in fact, there's various ways that you can control when the validations are run if you want to be more specific. So there's various points called lifecycle hooks where you can say, before you validate, do something to the model. So for example, you might want to canonicalize the date if the user entered the date in a weird format. Or if you're checking email addresses for validity, you might want to make the email address all lowercase before you actually do the validation. But the most important thing here is before it gets saved in the database, validations will be run. And if you remember way back to when we introduced active record, and there was the idea of calling save, or you could call save bang. When you created a new object, you could call create, or you could call create bang. now you kind of have some context for what's going on there. When you call save and it returns nil, or if you call save bang and it raises an error, usually it's because one or more of the validations didn't pass. So essentially, unless you specifically override, which I don't recommend that you do, Rails will basically not let you save an invalid object into the database, whether it's a newly created one or whether it's the update of an existing object, right? Because the validations will run, and if they don't work, the save actually does not happen, right? And if you're going to ask, yes, there is actually a way to force it to say, bypass all the validations, do what I say, and save the object. That is rarely a good idea, because when you're expressing validations, what you're basically doing is you're expressing invariants, right? An invariant is some condition that your code can safely rely on always being true. So for example, if you know that you have specified for a movie that the release date cannot be blank, then it is always safe for your code to, for example, compare the release date to something. If you didn't have the invariant of the release date cannot be blank, there's always some possibility that if you grab a movie that has a blank release date and you try to compare the release date with a date object, you'll get an error because you'll be comparing something with nothing. So validations are one way of saying, this is an invariant that I want to be true of any model that I choose to persist in the database, and it's at your own risk to sort of circumvent that mechanism, right? And it's also a way to put the knowledge in exactly one place about what those conditions are. You typically will find it at the very top of the active record model file. It doesn't have to go there. It can actually go anywhere in the model. But in terms of readability, think of it as almost a declaration of, here are the things that are always true about a movie. It has a non-blank title, which is never more than 40 characters. It's always got a release date, and it's never been released before 1930. Right? And then everywhere else in your code, when you manipulate a movie, you can take advantage of those assumptions to prune out some error checking. Okay? So validation automatically happens here, right before a save of any kind. You can also explicitly do it. You can call valid question mark on any instance of an active record object, and you'll get back a truthy value or a falsy value, depending on whether the validations all passed or if anything failed. And if they did fail, then first of all, you know that save will also fail. And you can also look in errors, which is an object that has cool behaviors of its own and stores all of the messages of why the validation didn't pass. A typical thing that you would do in this case is you would take whatever is in errors, you would put it into the flash, and then you would redirect back to wherever the user just was, saying, you couldn't save, this movie couldn't be saved or updated because, and then the errors will just list, here's all the things that went wrong. So that's one kind of point, cut, and aspect that Rails provides. Right? Now, you don't get to control exactly when it runs. Rails prescribes that it runs whenever you have a flow that is about to update the database. So it's not true aspect-oriented programming because you have no freedom to say when validations are automatically run. Rails decides that for you. You do have the freedom to say what the validations are. So the advice aspect is totally up to you. And as I showed in my simple example, there's a handful of sort of standard validations for checking things like, is it a number? Is it greater than or equal to something? Is it a null string? Does it have some number of characters? Common cases like that, there are built-in ones. And then you can also define your own function for my crazy validation of whatever I want. So in a model view controller app, the other place where sort of action happens is the controller. So there is a similar kind of AOP mechanism, aspect-oriented programming, that applies to controllers. And they are called controller filters, even though that terminology is sort of left over from Rails 2 or Rails 3. But people still refer to them as filters. And the idea here is another cut point, or point cut, another place where you can have something happen without explicitly calling it from the code, is right before some controller action is about to be done. So picture the moment in time, right? The user has submitted an HTTP request with some sort of a route. The routing system has figured out that the route maps to a particular action inside a particular controller. Immediately before the controller action is run, Rails will see whether there are any controller filters that might apply to that action. So let's take a look at what those controller filters can do. And the big difference between validations and controller filters is a controller filter can stop the show. Because it's the controller that gets control, as soon as something happens in the app, the controller filter can immediately it can sort of take over the powers of the controller action. It can immediately do a redirect, or it can choose to render a view and basically say, no, we're done. The original controller action is not going to be allowed to run for whatever reason. And instead, I'm sort of bypassing it and saying, this is how the request is going to finish out. And usually when it does this, this is the case when before it does a redirect or render, you've put something in the flash so that when that next page is displayed, the user will have some clue of why the controller action didn't fire. So what would this look like? Here's a simple example of one. This one is trying to capture the idea that most controller actions in this hypothetical app are only legal if the user is already logged in. So does that mean that in every single controller action you have to put a statement of the form if user is logged in? No, you declare it in one place. So I've hypothesized a function called setCurrentUser, which basically assumes that at some point in the past, somebody has logged in and we've stored their user ID somewhere in the session. So at this point, I'm basically setting at current user to, if it's not already set, to find whoever if there was a user ID stored in the session, then that means that that person somehow in the past has logged in. If that's not the case, then I'm going to redirect to some other action called login, and this is where the code would go to serve the login page. Okay? So this is going to get run because I'm saying up here, before action, set current user. What that means is, within this controller, before any action in the controller is allowed to run, on every single request, run this set current user function. And if the set current user function ends up not being able to set current user, in other words, if current user still ends up as nil, then it will stop the show by saying, nope, we're done here. We're going to redirect to the login page. And then the user can log in and we try again or whatever. OK, so my question is, what is the problem with this code the way that I have expressed it? And if you want a hint, in one of the previous homeworks, there were a flurry of Piazza posts about I'm getting an infinite redirect loop when I try to run my code. So before every controller action, I'm going to try to run this set current user. And if it's not finding someone in the session, it will immediately try to do a redirect and run the login action, which is supposed to give the user a chance to log in. What's the problem with this the way I've written it? Or more precisely, why will this formulation, the way I've written it, result in infinite redirects? Yeah?
The filter also applies to the login.
Yeah, the login is one of the controller actions. So unfortunately, the filter for making sure you're logged in will also be run before the action that logs you in. So you'll never actually get to this point, right? Because as soon as it tries to redirect, well, the redirect triggers an entire new HTTP request, which means the before action is going to be run again, and you're still not logged in, so you'll just infinitely go into this loop where you redirect to the login action. And the solution, as usual, is pretty simple. Right? When you specify a controller filter, you can say it should not apply to certain actions. Or if you prefer, you could say it only applies to the following controller actions. OK, let me pause. What questions so far about this? Okay, we've sort of defined two different ways that you can specify a cross-cutting concern and have that code invoked even without you explicitly calling it. Right? And the two ways that we've specified are validations, which apply to the model, and filters, which apply to the controller. They have many things in common. Both of them are examples of aspect orientation because they allow you to provide advice, some conditions that you are checking that you wish to make sure are true. They both rely on specific point cuts, and in Rails, the point cuts are defined for you. Validations are run during these lifecycle hooks, most importantly, anytime there's a save. Controller filters are run before and or after. You can also specify filters that run after a controller action. So for example, you can log somebody just did something. Somebody just updated the super user record in the database. I allowed it to happen, but you can run an after action. Validations cannot on their own change the flow of execution. Now, you can, in your controller, you can, before trying to do a save, you can run the validations. And if the validations fail, you can report that fact to the user and have them try again. But you have to make sure that happens. The act of a validation failing does not, in and of itself, cause a visible control flow change from the user's point of view, whereas the controller filters can do that. The controller filter can say, we're going to cut off the action right now, either with a redirect or by rendering a different template than the one associated with the controller action that was protected. In both cases, you can provide an arbitrary function. In fact, for controller filters, that's the only way to do it. There are no shortcut controller filters. Whatever the filter is, you have to provide a little piece of code that says, here's the conditions I'm checking, and if the conditions fail, you have to decide in that piece of code what to do. Render, redirect, blow up the universe, whatever. And if something goes wrong, the errors are stored for validations along with the errors object, which is part of the model. You get that for free. And in the case of a controller filter, because you're writing your own code, you have to decide how to make visible to the user what happened. And the most common way to do that is, for example, you put it in the flash, and you just arrange for every page in your app to check if there's something in the flash, make sure you always display it. It's a fairly common Railsism, because since the flash tends to be used for messages like that are ephemeral, it's typical for like every page in the app to have a place where if the flash has something in it, just show whatever it is. Okay, so that's kind of the summary. Again, my goal is to give you the high-level version of how this works and to frame it in terms of aspect orientation, which is actually kind of an important idea in programming systems. So Rails is not sort of fully aspect-oriented, but you get specific aspects that you can use, in this case, validations and filters. And there's a question.
Can you explain again why validations don't change execution?
Why do validations on their own not change the execution flow? Essentially, when you at what point does a validation try to happen? It's happening right before you do a database save. At that point, suppose we assert the opposite and say, well, validations should be allowed to change the control flow. The question is, what could it do? Right? What would be a reasonable thing for it to do? Because for a controller filter, you know exactly the moment in time when a controller filter runs. It is right before the moment when your own code in the controller is about to be handed control of the HTTP request. So the controller filter runs at a very predictable point in the workflow of model view controller. However, validations could be triggered anywhere. They could be triggered deep in your model methods. They could be triggered from your controller. So there isn't sort of any single strategy that would make sense for how to change the execution path if you don't really know what the context is when the validation is done. For example, if you have a complicated interaction where you're trying to save 3 or 4 different models at once, and only one of those models fails validation, what's the right thing to do? Well, you can decide in your code what the right thing to do is, but there's sort of no automatic answer to what you should do. But with a controller filter, the sort of time and conditions under which it runs are very, very narrowly defined. So a reasonable thing to do is say, well, if the controller action is not going to be allowed to proceed, what other option do we have? Well, it's HTTP. We have to do something. We have to either redirect or we have to render. So we can just put the redirect or render call right in the filter, right? But it's because it's running at a very, very highly constrained moment in time. That's why there's an automatic way to do it. Good question. By the way, is there any downside to doing all this stuff? There is always a downside, right? Anytime you add a mechanism that is intended to save you some work as the programmer, there's always the cost that if you overuse the mechanism or if you use it poorly, you might actually end up making your code less readable. And in this case, a standard critique of AOP generally is that if you overuse this, it can make the code hard to debug. So for example, you're debugging your app. You think that there's a problem with some controller method. You put a bybug statement so that when the app hits that controller method, you can like drop into the debugger and look around. And then you try running the app, and it never hits the debugger. And after hours of debugging, you figure out that there's like some long chain of before filters, and one of the before filters decided that something wasn't good, and it stopped the show. And unfortunately, whoever wrote that before filter didn't put anything in the log file, didn't put anything in the flash. So you sort of had no clue of like where in the chain of events did something not work the way I thought? Why didn't my controller method get called? Oh, I see. It's this before filter, and there's also this one and this one. So as with all such mechanisms, you use them judiciously, right? If you find that your controller has like 5 or 6 before filters, something is wrong, right? You should be asking yourself, did you define your controller in such a way that it's being asked to check too many conditions, things that are not necessarily its responsibility? So use responsibly, right? Just like cigarettes and alcohol, or at least alcohol. OK, so, that was on tape, wasn't it? OK, that's fine. So the sort of conceptual summary here is AOP is a way of drying out what are called cross-cutting concerns. The pro is exactly that. You define a concern in one place, and there are now many places from which it will basically automatically be invoked for you. The downside is there are many places from which it will automatically be invoked for you. And if you overuse the mechanism, it can become easy to sort of lose track of what the straight line control flow of the code is. Rails does not have full aspects. There are some languages that do, but it provides these two specific flavors of it because they make sense in model view controller. For a model, you want to check whether certain things about a model instance are always true. For controllers, if you want to check whether some conditions are true before letting the user action go forward, and if not, you can sort of shortcut the situation. We are not going to talk about in lecture, but they're super simple to understand, so please watch the video or look in the book. Partials, which are basically little pieces of a view that you can use to build up views. So if you've got some common content that gets reused in many different views, you can essentially pull it out into the moral equivalent of a view subroutine and include it in many different places.